Welcome, everyone, to our fourth live stream of All Things Automotive. If you're curious to learn about what AWS is doing in the automotive industry, you've come to the right place.
Yeah, this is a show where we dive deep in the auto tech news, look at the emerging technology, talk with our AWS customers and partners, and our own specialists on some of the most important issues in the automotive industry.
We have an exciting season with at least 8 episodes, all themed around Edge to Cloud, with a focus today on our partnership with NXP.
Microchips, Internet of Things, and machine learning. Love that. Ready to start your engine scene?
Absolutely, Stefano. Let's roll. Welcome, everyone. I'm Dean Phillips, Worldwide Tech Lead for Automotive at AWS.
Hi, I'm Stefano. I'm Principal Specialist Solutions Architect at AWS.
I'm based in the Motor City, Detroit, Michigan. I have automotive in my blood. I have a passion for cars and everything about them. But if you combine that with my love for technology, I can't think of a better industry to be in right now, and a better co-host to do the show with. Take it away, Stefano.
Thank you so much, Dean. It's really awesome to be here with you. I'm from the Italian Motor Valley, land of good food and powerful engines, but loving computers as well. Now I'm in the Silicon Valley in California to try to get the best from cars and computers. And as the perfect and most ambitious combination of the two, right now I'm really focused on autonomous vehicle technologies.
We're excited for what we have planned for the show. We've organized all 8 episodes around the theme of Edge to Cloud and back. And here's a member of our All Things Automotive team, Julia McAndrew, to tell you what's up ahead.
In this week's leg of our journey from the edge to the cloud and back, we're exploring an ecosystem that is swiftly moving from horsepower towards compute power. For episode 4, our hosts Dean and Stefano look into how AWS fills the tanks of innovation with that precious fuel, data. Services like AWS Analytics and AWS Greengrass V2 are delivering valuable vehicle insights, enabling data-driven service revenue, and expanding access to real-time information. Let's accelerate our insights with all things automotive and talk machine learning inference with NXP.
After that, I'm ready to go on a road trip. What about you, Dean?
Absolutely. My bags are packed and ready to go. But before we bring on our guests, we'll kick things off each week with a little discussion about current events in our industry. So let's get things going, Stefano. What's driving the news these days?
So, Dean, since we are talking about chips in this episode, let's start with a few news about from the semiconductor industry, right? So first one, ARM announced their ARM9 architecture. And why is this important? It's really important for us talking about IoT and devices because ARM is the most commonly used architecture for mobile devices and cars, right? Given their efficiency and using safety-related configurations. So what's new with these chips, with this ARM9 architecture? So they announced 3 main areas: security, artificial intelligence, and DSP, digital signal processing capabilities, right, to analyze signals coming in. All these features are really, really important for the automotive industry, right?
In fact, ARM presented this chart at their Vision Day, which explains how CPUs, GPUs, and neural processors are all being used for AI and ML. And as you know, we've been talking about this transformation of in-vehicle compute on the show and all of the trends related to it moving forward. As you know, ML isn't just for perception and path planning on ADAS modules. Clearly, there are other use cases for ML, and with ARM9, developers can actually exploit these powerful CPUs for pattern training and text signal analysis, reading license plates, for example. And this opens the door for intelligent deployment of models according to their computational characteristics. It's a really interesting trend, and I think our guests later will actually talk a little bit about that.
Yeah, it's super cool, and we see it in the cloud, right? It's not just an ARM trend, by the way. I recently saw this paper from Rice's Brown School of Engineering, where they were able really to run on an Intel CPU architecture to run deep neural networks faster than in a GPU on some specific artificial intelligence cases. Sure, it's a specialized case, but it's interesting again to see all this research on algorithm and compute options together, right? So I have the impression that some major breakthrough is needed to achieve faster and sustainable artificial intelligence improvements for full autonomy.
Well, talking about ARM, one more thing that's important, they announced their Neoverse N2, the next generation of their data center grade chips, which is actually the architecture we use to build our own Graviton 2 instances with. And in fact, we're the only major cloud provider that has ARM chips in the cloud.
Yeah, that's very interesting too. We're seeing some really very cool stuff implemented on Graviton 2 by our customers. And so maybe we should dedicate an episode for that. But it's not just good news about chips, right? What's happening about chip production?
Well, as you know, we've got the perfect storm of factors. Let's see if I can get this thing centered right. The Automotive News described this perfect storm actually this past week, where 80,000 vehicles were actually taken out of production schedules across Ford, Stellantis, and GM. And if you think about it, Ford and Stellantis, they've been taking the largest hit on this microchip shortage. In fact, Ford's 2021 production is reduced by about 1.1 million vehicles, which explains why, when you go by a dealership, you can see these lots just look empty sometimes. I saw that myself just recently. And this cuts their profit by about $2.5 billion this year. And it all begs the question, about the vulnerability of our supply chain and what we're going to do about it.
Yeah, even President Biden and the EU Commission chimed in on this. And by the way, yeah, this is probably given to the pandemic and all these conditions, this absolutely weird year. But maybe it's just even an initial sign of the IT and the EV, electric vehicle revolution that will come in the next few years, right? Surely a lot of things will change, and the magnitude of this radical shift towards electrification will have major consequences on the supply chain. So everything is connected, right? Even in terms of supply chain, production, not just the objects of the internet. And by the way, electric vehicle revolution that probably will be even more accelerated by recent announcement by the Biden administration, right?
Yeah, combine that with what California's already announced and some other states. The administration proposed $15 billion to fund the rollout of EV charging stations across the country, with a goal of 500,000 to be completed by the year 2030. And that's a lot of juice behind our Rivian EV delivery trucks, if you think about it. But the proposal doesn't end there. It includes electrification of transit and school buses, federal fleet of vehicles as well. And all, consider all the incentives that are going to be incenting people to buy these EVs and modernize our infrastructure. So that's quite a push for electrification.
Yes, absolutely.
I know we could talk on and on about this for automotive news for hours, but why don't we go ahead and move on and start introducing our guests?
Sure, that's right, the next step. So our first guest is Kurt Hillier from NXP. Hey, Kurt, nice to have you here. And why don't you tell us a little bit about yourself?
Yes, hi, I'm Kurt Hillier. I'm with NXP. I am a technical director in the Automotive Solutions Group, and I'm based in Austin, Texas.
And our second guest is Alejandro. Why don't you go ahead and introduce yourself, Alejandro?
Sure, thanks. And hi, once again, my name is Alejandro Lozano. I'm an embedded applications engineer here at NXP. I joined the automotive family at NXP just 1 year ago, and since then I've been working with software enablement like Greengrass and demos for the S32G2 devices.
Yeah, and talking about demos, we have one of our devices wizards, Scott Francis from our IoT team here in AWS. Hi, Scott.
Hey, Stefano. Good to be here. Nice to see all you guys. Yeah, I'm a partner solutions architect with AWS, and I've been working with NXP over the last year to help use our connected mobility solution to visualize the electrification of their components.
There you go.
Hey, thanks, Scott. Thanks, Alejandro. and Kurt. Hey, we're so glad you all joined us today, and we're really looking forward to learning what you have to say about this really important topic in our industry. So now that we've done our introductions, let's get under the hood with NXP.
So, Kurt, tell us about the recent announcement around the S32, right, the offering, and why partner with AWS? Why you're here today with us?
Yes, NXP is excited to work with AWS to enable the next generation of connected vehicle services. We believe incorporating cloud-based processing and data management at the edge using the S32G processor provides a lot of value for our customers. The S32G provides that high performance compute at the edge to offload some of the cloud services and really bring a complementary solution to the market. We do this offload and processing, and there's really three things that come to mind that can help our customers. One is you can get faster response times by doing compute at the edge. You might be able to save data transmission costs to the cloud. And you can do things like data logging and event-based data acquisition. So all three of those things we think are really attractive. The goal is really to enable services and try to manage and save costs at the same time.
Yeah, when you consider the consolidation of ECUs into domain controllers, you really start to understand how the vehicle gateway plays such an important role. So Kurt, talk to us a little bit about the different offerings you have in the S32 line. What's the difference between these green, gold, and blue boxes that you have?
Okay. Yes, we've developed the three boxes, the gold box being the gateway, green box for electric propulsion, and blue box for ADAS and autonomous drive to serve as development platforms for our customers. Blue box is really the most highly performant box of the system. It has a Layerscape processor with a high number of the ARM A72 cores in place. It also has a vision processor, the S32V2. And then finally, you can add an AI ML acceleration card based on the Caloray device to really boost the amount of AI and ML that you can do in that system. We can intake a LiDAR, radar, and camera inputs into Blue Box and do that autonomous drive and ADAS development. The second box is Green Box, and that's the one that really moves the vehicle and moves it efficiently and safely. So if you think about electric motor control, combustion engines for hybrid vehicles, as well as battery management systems, the Green Box is really in charge of kind of the hard real-time ASIL-D safety level processing for those what we call actuators, really the physical blocks in the car. And then finally, Goldbox brings everything together. It allows you to connect all those vehicle domains securely within the car, and then also allows you to provide an interface to the cloud securely. And that's where the Greengrass software comes in. The Greengrass, AWS Greengrass is running inside Goldbox to do a lot of that connectivity and deployment. So,
yeah, that's really interesting.
Yeah, go ahead.
Sorry. Yeah, no worries. That's absolutely super interesting, and that's so interesting that I'm really curious to get a little bit inside this box, right? So, considering the three boxes, can you talk to us a little bit more about what's inside this gold box and the role of vehicle gateways in today's vehicle architecture?
Yes, sure. Goldbox is NXP's service-oriented gateway reference platform. And as we've mentioned, it contains the S32G processor. The key strengths of the S32G are its mix of application cores and hard real-time cores, as well as built-in networking accelerators. For the network accelerators, what this means is that you can take in a high number of Ethernet channels, as well as CAN messages, process those without burdening the centralized CPU cores. So it's definitely a key advantage of the NXP technology. And then finally, I'll just say that for NXP, it's just not about the silicon and the hardware anymore. You have to have software, you have to have systems and tools, capabilities, and that's also where we're really strong. Alejandro, can you say a few things about the AWS Greengrass integration in Goldbox?
Sure, that's not a problem. Well, the S32G has an entire software ecosystem, and AWS Greengrass is only one of the components, right? Greengrass is enabled in our Linux Automotive VSP in three different platforms. The RTB, which we can see at the top, Goldbox, which is obviously in the middle, and the EVK, which you can see at the bottom. We enabled Greengrass using Yocto, providing a Yocto layer on top of your Meta AWS layer as well. So the customer is able to tailor his own distribution without any hurdle, right? And of course, besides providing Greengrass or basic Greengrass, we are working to enable these hardware features in the S32G. For example, using security and key management inside on the chip, using the hardware security engine, the packet forward engine to offload the CPU in high bandwidth networking applications, GSN enablement, and AI and machine learning hardware accelerators. All of this in Greengrass. And I guess that for details in Greengrass, we have Scott who can provide more details about it.
Yeah, Greengrass is AWS's edge compute platform for IoT. And as Alejandro mentioned, we include features such as access to hardware security modules, the ability to have that as a hardware root of trust for executing Lambdas at the edge, executing containers, to do AI ML, to do signal acquisition, and to even do things like message compression so that you can reduce the amount of bandwidth or the amount of messaging that's egressing the vehicle. One of the exciting features of AI ML is also to do anomaly detection on the edge or even create synthetic sensors.
It's really cool. I mean, there's so many capabilities with what Greengrass brings to the picture, on the vehicle gateways. Alejandro, you guys developed a model to predict the remaining usable life of the battery, and then you deployed it on the device. How did you do that? And did you leverage Sagemaker in any way?
Yes. Well, to be honest, I think the most difficult part in that was getting the correct data set, right? But after that, the use of this cloud service for data scientists called Sagemaker added a great value and helped to reduce the development time. In fact, we use Sagemaker for two different use cases. The first one is the calculation of the remaining useful life, but of the engine. The model is an LSTM network and the inference is done in the cloud. The second one is to detect anomalies in the battery pack. The model uses a built-in algorithm called XGBoost, and the inference happens in Goldbox using deep learning runtime from AWS. And with Sagemaker, we were able to build the neural network, use this built-in algorithm for each use case respectively, train them and deploy them in the cloud and in the target as well.
Yeah, we used Sagemaker Neo to optimize that model for the target hardware. With Sagemaker Neo, we can create a compilation job and an optimization job that's specific for the execution architecture of the S32G. Like Alejandro mentioned, to create some of the data sets we used for training, we took a collection of both natural data, observations, as well as synthetic data, moved them through an RCF or random cut forest algorithm to build a training set for the XGBoost algorithm that could be run in vehicle.
Yeah, and it's super interesting to see how you can use Sagemaker Neo, right, to sort of, let me be, say, a little bit high level on this, to abstract from the final hardware, right, create a model and then really optimize for a specific CPU, GPU, neural processing. So that's really interesting. And it's so interesting to see as well this, hard real-time cores, application cores, the security island, the security area where you can store a piece of information. So it's really interesting. And in all this revolution, these new elements and very, very performant elements, how's really the cloud going to help, Kurt? What other functions can we support with this bundle, right? With this powerful hardware platform and software and the cloud?
Okay. Yeah, there's really two thoughts that come to mind at the very high level. The cloud can help us in that connectivity. It can help us in two ways. The analysis of data from the vehicle and the fleets is the first way. And then the second way is the deployment of new software to the car. For the first topic, when we consider data analysis, there's a few use cases that come to mind where we're already seeing the ability to save cost and make a little bit of profit. It's usage-based insurance, and that's where the driver characteristics, you can save money by opting in to an insurance program that if you're a careful driver and obey the rules, you save a little bit of money on your insurance costs. So that's very attractive. The vehicle health monitoring is another application where we're able to observe the characteristics of physical components in the car, and we can make decisions on when does this car need to get in for service for this particular component, because we can see a certain type of behavior. So that's the second type of use case there that's attractive. And then finally, I think for fleet operators, just the ability to monitor all of your vehicles across the world, different regions, different environments, hot environments, cold environments, and track the health and the capabilities of your cars and your trucks and your delivery vehicles across the planet is very valuable. The second major high-level thing I talked about was software updates. So we can picture a scenario where your vehicle is never out of date, and you don't have to bring it into the factory or the dealer for a recall. Software patches can be deployed to fix issues, and then there's the ability to extend range or provide entertainment packages. Your car can always be tuned to your needs, and it can be updated. So I think that's the other second major one where it's really attractive. And talking about the solutions, just as Scott was mentioning and Alejandro, the major attractiveness that we have is the ability to run algorithms wherever it makes sense. They can run in the cloud, they can run at the edge, they can run really close to the actuators. So that's what NXP and AWS bring in, is this ability to run your decision making and your intelligence wherever you need to run it in the chain. So Scott, can you tell us a little bit more about the machine learning aspects of our collaboration?
Yeah, sure. Like Alejandro mentioned, we started with running predictive maintenance in the vehicle on the battery pack, so we can look at remaining useful life of that vehicle. You can extend that ML to do things, detect driver events like hard stops, fast accelerations, other things that might affect business models like usage-based insurance. It's appropriate to do that in vehicle, where you're close to that data, closest to that data set, and then you can minimize the amount of extraneous traffic or things that might be sensitive to go from the vehicle to the cloud. And then in the cloud, you can run aggregate models across the entire fleet. Perhaps all the different models from a different OEM, all the different battery pack models, all the different BMS controllers, other types of systems to detect faults, trends, or in the case of usage-based insurance, develop a more accurate picture of the risk pool. This can even create its own data package, which can be sold in part of a data mart and exchanged with other providers and other carriers. CMS, our connected mobility solution, pulls it all together and provides a fleet manager, where that fleet manager is an operational fleet or an OEM or component maker who might want to visualize the different types of exceptions, faults, trends that are happening with their components or within their operational fleet, to look at which systems do I need to pay attention to, which vans are going to need preventive maintenance soon, which drivers are excessively hard on the vehicle, or any other type of model where you can focus in on the exceptions that are happening on the fleet rather than on every data point all the time.
Good. Yeah, Scott, I mean, it's just amazing to really think about, the application of machine learning and artificial intelligence in the vehicle, in the cloud. When we talk about how customers are investing in this space, I don't think we really understand the enormity of it. And the ability to leverage our services to deploy on technologies like what NXP provides. So anyway, thanks a lot, guys. This was a great discussion. We have so much more to discuss. And now's the time when we go to our In the Shop segment, where we kind of roll up our sleeves and dive into the nuts and bolts of the topic. And so, Stefano, why don't you pop the hood and get us started?
So, Kurt, Alejandro, Scott, today we have a very cool demo to show, right? It touches a lot of the relevant trends in this industry we discussed even in the news section. So who wants to start? Maybe you want to give an overview, Kurt?
Yes. So let's take a look at the graphic here, and we can show you how the demo system comes together. In the middle, in the right-hand side of the diagram, you'll see Greenbox 2, the powertrain domain controller, and you see several things attached to it. You see a battery management system and then 2 electric motor drives. All of those hardware systems are enabled by NXP silicon and software. And what Greenbox 2 does is it actually manages the electric motor drive, reads the battery voltages, and incorporates a battery management system algorithm. So that's really the propulsion, the electric powertrain portion of the demo. And then I think we can drill into that just a little bit more. Yeah, so here you can see the major blocks inside the system. Let's start at the bottom and work our way up. At the bottom are the ARM Cortex R52 cores. Those operate in lockstep to give you redundancy checking for high safety integrity level applications. We have 4 of those lockstep pairs, and they operate at 800 megahertz. On top of those is a Type 1 hypervisor provided by Open Synergy, and this allows you to isolate the applications and create virtual machines such that you can have multiple what we call electronic control units, or ECUs, that can operate in the system at the same time. So our 4 major applications that we're running is a dual instance of the inverter control, that's the electric motor control. We use an automotive math and motor control library from NXP that is optimized to run on the hardware and is specific for doing math computation. So that's the dual inverter control. The battery management system is all about reading battery voltages, trying to do state of charge and state of health prediction. And then there's a secure communication stack, which allows you to bundle some of this information and send it out to the S32G. Finally, the application that rides on top of all of those lower level functions is an energy management system. That's an algorithm that's developed by the Mathworks. It's called Adaptive Equivalent Consumption Minimization Strategy. And its whole job is to make sure that we are being efficient with the amount of energy that we're using in the vehicle as it moves down the road and corners. So it's really an energy supervisor that's provided by the Mathworks.
Yeah, it's really interesting. And what's inside the gold one? That's the place where we have the biggest part of the AWS stack, right?
Yes, that's right, Stefano. Actually, before that, I think it's worth mentioning that we're also using the AWS IoT SDK on Greenbox 2. But on the S32G, this is the processor that is executing Greengrass core. It, of course, uses the MQTT broker with TLS to communicate securely with Greenbox 2. Gathers the data and sends it to the cloud to be processed by different AWS services and solutions like CMS. And it's running a Lambda function to do the anomaly detection of the battery pack using the deep learning runtime as well.
Yeah, it's really cool to see this, how you've applied the connectivity between the Greenbox and the Goldbox. We've always talked in the past about the potential of using MQTT to do this between the major controllers. So it's awesome to see how you've implemented it. But, combine that with, the cloud aspect and CMS. Scott, why don't you kind of talk to us how that accelerated the deployment for this project and, and what role it played?
Sure. So CMS functions kind of as a data scoop. Like Alejandro mentioned, some of that raw data is starting with the device controllers in the Greenbox, communicating that to the Goldbox as a gateway. And then CMS scoops all that data into a cloud-based data lake where we can do different types of visualizations, such as trip planning or trip review. You can even predict or estimate costs for that particular trip. And if you're operating a fleet, look at which routes might be most expensive or ones you might want to take advantage of or stop delivering on. All this is possible once you aggregate all that data in the cloud and provide a visualization layer like CMS.
That's cool. Hey, now that you've kind of given us the big picture overview on the solution, why don't we take a look at the demo?
So here's the demo. This is a picture of me and describing the demo overview. So I'll go ahead and do a voiceover what we're looking at here. We've already iterated how the demo is put together. So you've seen the powertrain domain control hosted by Greenbox. You've seen the Goldbox acting as the service-oriented gateway with IoT Greengrass. And then finally, we've got the connectivity to the cloud running the connected mobility solution. So we're going to see how those operate together in the demo. There's should be three major use cases that we highlight, and that is the, there it is, predictive maintenance, advanced vehicle diagnostics, and then telematics and fleet management. Here's the demo overview. You got the motors on the right, the battery management kit at the top, Greenbox and Goldbox. Now we operate this demo with a Simulink-based simulation, and you'll see that we start to drive the car down the test track. We've got vehicle metrics over on the right, and you can see that the electric motor wheels are spinning in conjunction with the vehicle speed. As we drive down the track, you can see more detail on the vehicle metrics. One algorithm that we have running is called a torque vectoring algorithm. Since you've got two electric motors, you can apply a different amount of torque on the left and the right wheel, and that assists with steering and even braking. So here's the, again, more description on the Simulink side of things. The Greenbox has knowledge of the vehicle data. It's passed to the cloud. This is the picture of the connected mobility solution from AWS, and we'll click on our car here. We can see our generic sports car, and then this is an overview of the M-City test track. So as I start to drive the car, well, first of all, we'll talk about the metrics. We've got software version, trouble codes, odometer, battery charge, current speed, and then remaining useful life, all being calculated. As we drive the car down the test track, we have GPS coordinates in the simulation. Those are also passed over to the mapping software. And you can see our little blue GPS dot is moving in coordination with the vehicle location. And I think that's about all we have to report on there. It's a pretty nice system. It shows really well. And yeah, that's what we've got.
It's really, really amazing to see the whole end-to-end system, right? The car simulator providing car data, flowing into the system in the real hardware, right? And going back to the cloud and the CMS. Really, really awesome demo. It's wonderful, really. It really made me understand how the whole process works. And Kurt, just a curiosity, since today, right, it's happening. There's the MATLAB Expo going on. So I saw some MATLAB Simulink components in there. And are you using model-based design, right? And as an approach, and it was very nice to see that integration.
Yes, I can make a few comments on that. That's in partnership with the Mathworks, and we license their powertrain block set and their vehicle dynamics block set. The interesting thing about the vehicle dynamics block set and the car simulation that you saw is that is being developed with the Epic Games Unreal Engine. And I believe what I've heard is that there were several University of Michigan students that were so excited about the plugin that they helped craft the M-City test track as the environment that you saw on that simulation. So it's fun to work with. But yeah, you highlighted the NXP model-based design toolbox. We've worked very closely with the Mathworks over a number of years, that when you have an algorithm that's written in MATLAB or Simulink, you're able to do a code gen process on it using MATLAB Coder or Simulink Coder. And then our model-based design toolbox plugs into that C code. It basically absorbs it. And then we have knowledge of our hardware platform. We generate an ELF file that's optimized to run on a CPU core or an embedded DSP. So it's a very powerful tool set that we're very proud of. It works across a lot of our microcontrollers, and it helps any of our customers that are doing MATLAB and Simulink model-based design. One comment I want to add before we go on to the next point is that when we saw the demo, we don't just pass GPS coordinates, but we can pass battery cell voltages, temperatures, current, we can pass motor torque, engine torque, any of the parameters that are available in that domain can be sent to the gateway. So I wanted to highlight that. It's not just GPS. So.
Yeah, that's true. I mean, there's so much data that's available, to send to the cloud for analysis. The opportunities are endless there. We always talk about having too much data. But, you mentioned a lot of the content we're getting from MATLAB. What about the role of Neo, Sagemaker Neo in the solution? Can we dive a little bit into that, Alejandro?
Yes, sure. Just like I mentioned before, we have two use cases, right? We use Sagemaker Neo, the second one for detecting anomalies in the battery pack. The way it works is that once we finish training our models in SageMaker, there's still the need to transform that model so our target can execute it, right? This is where SageMaker Neo comes in. We used it to optimize it and compile the model to the correct architecture, in this case, the S32G2. To be honest, it was a matter only of a few clicks, a couple of lines in Python, and Greengrass configuration to deploy it.
Yeah, Greengrass provides a facility for keeping those models up to date. So while Neo compiles the models and targets them for the specific hardware architecture, as part of the SageMaker umbrella, SageMaker Edge Manager integrates with Greengrass on the device core to provide model updates. So as we iterated and we developed new versions of the model, we could push them down to the device and do that in a managed framework. While we were doing this for a demo, that exact same solution could work for fleets of thousands or millions of vehicles.
Really, really nice. And I really like to see, this is the demos of the demos. In fact, it's really impressive to see all these components working together, IoT, cloud connectivity in a secure way. Because again, that's respected, safety, integrity, the lockstep processors working together to guarantee redundancy in terms of execution. It's really, really awesome demo. I loved it. And Scott, why don't you tell us a little bit about the AWS architecture specifically? So the cloud box, right, that we saw on top of the previous picture of the diagram. So how does that work?
Sure, there's a lot of components inside that little box that's at the edge of the diagram. As I mentioned before, the function for CMS is really kind of a data scoop or a data pipeline. We're taking data items from that edge environment, from the green box, from other sensors that might be on the CAN bus or other places in vehicle, even synthetic sensors that might detect like a hard stop or people in a car, and then ingesting all that data over MQTT to the cloud, coming into AWS IoT Core. And then from there, we have a layered structure of different types of actions that can be applied on that data, both as it's coming in, kind of on a streaming basis to detect anomalies, unusual conditions, record and capture data like trips so that we can create an archive or a data lake that can be used for further research, or in batch mode, where you might want to look at an accumulation of all vehicle traffic over a month or so. We store all of this information in a centralized database using Amazon Elasticsearch as that repository. And the reason we chose Elasticsearch for this is because of the strong geoquery nature, as well as its extreme speed and scalability. On the far right edge here, we have the visualization components. We saw earlier in the demo the dot moving around on the map, and previously we saw a visual where we had the trouble codes and other types of things looking on there. Those are just examples and just one way that you could provide analytics and visualization into this data set. This was delivered with a static React application going through an API gateway to query that Elasticsearch database. Other dashboards are possible, such as things that monitor state of charge across a fleet, driver usage, could be tabular, could be exception-based, could be type of anomaly detection. It doesn't always have to be moving maps. That's part of the great flexibility of CMS.
Yeah, thanks, Scott, for that overview. I mean, as you know, we've been working so hard on this solution, the CMS solution, to bring it out to customers over the past couple of years to accelerate their deployments. Really excited to see it applied in this example here. And in one of these days, we'll eventually get a one-click install for all you guys out there that want to play around with it. I know it's taking forever, but just stay tuned, it'll be there. But overall, this has just been such an amazing topic, great session with you guys from NXP, and thanks, Scott, for participating as well. I love seeing how deep we're getting into the vehicle, with technologies like what NXP provides. So that said, thanks so much for all of you. and I really can't wait to see where this partnership takes us.
Yeah, thank you so much. It's been really awesome content, and it was really good to see from chips to architecture, cloud all together. And this really provides a very big picture, but a detailed one, a deep one. So I really loved it. Thank you so much, Kurt, Alejandro, and Scott.
Yeah, thank you to the AWS team, and we've enjoyed the collaboration we've had so far, and we're really looking forward to additional demo developments. We're not stopping here. This is a living, breathing engagement, and we'll be doing more. So yeah, thank you very much.
Yeah, thanks so much, everyone, and yeah, once again, thanks for having us here.
Absolutely.
It's been a pleasure speaking with everyone today. Thank you.
Awesome. Well, thanks again, Kurt, Alejandro, and Scott. Really appreciate you being here today. But now's the time in our show where we take a look at upcoming events that we think you guys might be interested in or you might enjoy. And so, I don't know, Stefano, why don't you talk to us about what's coming up around the corner?
Yes, this is a segment where Dean and I share what we think are really interesting events and resources. And we're certainly heading into a season of great ways to learn more about innovations in the automotive space. So what do we have coming in the next week? By the way, not just next week. I think that something is going on right now.
Yeah, absolutely. The MATLAB Expo is actually in progress. It's an awesome event. You know, we've highlighted how it's being used here today with our conversation with NXP. Clearly, anybody in automotive knows it's a critical technology that it really accelerates engineering. Our own AWS Luke Harvey, he's our automotive partner solution architect, and Mathworks Gandharv Kashinath are presenting today around cloud data workflows for automotive. Well, I don't know about today, but soon.
Yes, absolutely. And yeah, by the way, I think that NXP is there too. So interesting. You see both companies in the event as well. So very nice. So we'll also be at the ATZ, Automated Driving Conference on June 9th, where our Brian Beresdevin will have a session on the autonomous driving data lake to increase development efficiencies.
Yeah, that'll be a good one too. But as you know, I think it's a little bit premature, Stefano, but I can't wait for you to show me around the Italian Motor Valley this summer in July, where we'll both be speaking on some exciting topics at the Italian Motor Valley Fest. But I really want to know, do you think you'll be able to get me a ride in like a Lamborghini or a Ferrari or some of those beautiful Italian sports cars?
Yeah, of course, I'll do my best, Dean, but you have to promise to stay away from the vino before I toss you the keys, right?
I know. Yeah, not before driving, but definitely after. Looking forward to that. It's a deal. So hopefully you guys have enjoyed the show today. And David Hale, he's our chat moderator, is answering questions you've brought up. Hopefully that's been valuable. And he's been sharing some interesting resources that you guys can use. So hopefully that's been good.
Yeah, and if you are catching this on demand, just send along comments or questions to Media Series Live Streams at Amazon.com or use the hashtag AllThingsAutomotive.
And the show doesn't end here, of course. In 2 weeks, we'll be back with Josef Wiehauser from BMW, where he'll be talking about their enterprise cloud data hub.
Yeah, and our colleague Junji from AWS will be there too to go over our recently updated autonomous vehicle data lake reference architecture. And Junji is awesome. And Dean, you authored with him a nice blog post on autonomous data lake, right? So really, can't wait to hear what is going to cook for us in that episode. So I always learn something from Junji.
Yeah, Junji's great. And the team that he has working for him with customers like BMW really create some amazing solutions. So it's going to be a great show. So that about wraps it up for our 4th episode of All Things Automotive. We hope to see you back next time.
Thanks so much for joining us, and see you next time on All Things Automotive.